In this video, we're going to talk through the 0A4 warm-up or the 0A4 practice on box plots and histograms. So it says, Ms. Humphrey asked her students to choose a number between 1 and 50. Ms. Humphrey recorded the data and made the box plot shown below. So we got this box plot. So what is the median number that was chosen? Well, I know that looking at the box plot, the median is always this number right here, so the median is 30. What were the minimum and the maximum? Well, if this is the median, I know that the minimum is the lowest down here, and the maximum are found at the very end, the highest. So the minimum was 5, and the maximum, or the highest number that anyone chose, was 49. So no one chose 50, and down here no one chose 4, 3, 2, or 1. So it's about what percent of students in Ms. Humphrey's class chose numbers above 15. So 15 is the lower quartile. I know that each section in here represents about 25%. So this is about 25%, and so on. So above 15, while I'm looking at 15, above it, we have 25 plus 25 plus 25, or 75% of students chose above 15. So 75%. Did a student choose a number 4? Explain. So we're looking down here. Well, 4 is below 5. If 5 is the minimum, then that's the lowest number anyone chose. So no one chose 4. So did the student choose number 4? No. And the explanation is that the minimum is 5, or the lowest value that a student chose was 5. Look in here. Did a student choose the number 27? Well, where's 27? 27 would be right about here. Well, 27 is falling in this block. So when I look at that, I don't know for sure whether or not 27 was chosen. In fact, the only numbers I know that were for certain chosen was 5, because that's the minimum. I'm telling you, the lowest number anyone chose was 5, and the maximum 49. I'm telling you, the highest number anyone chose was 49. The rest of these, we have the median, and then the lower quartile, which is finding the median of the lower half, or the upper quartile, which is the median of the upper half. We're not even guaranteed that 15, 30, or 40 were any of those values either, or any values that were chosen. When we look in between, it's possible that someone chose 27, but it's not necessarily true. So when I asked, did a student choose the number 27, we would say it is possible, but cannot be determined. And then scooching down here, 24 students were surveyed. Okay, so now we know how many students are in our class, 24. How many chose numbers between 5 and 30? Well, let's look up here. 5 and 30, we're going from our minimum to our median. Our median cuts everything in half, so below the median is 50%, or you can look at this as two sections of 25% each. 25 plus 25 is 50%. So we're saying this is really 50% of 24. There's a couple different ways you can think about that. 50% of 24, you can do 50% as a decimal, 0.5 or 0.50 times 24, and you will get 12. Or if we're saying, well, 50% is just half, I can say half of 24 is 12, or half is the same as dividing by 2, so 24 divided by 2 is 12. All three of those algebraic methods are ways you could figure out how many students chose between 5 and 30. So I will say 12, and I'll keep units on my answer, 12 students. Looking over here, between 30 and 40. Well, between 30 and 40, that's between the median and the upper quartile. That's just one section of 25%. So this is really saying, what is 25% of 24? And we can do it the same way. We can make that a decimal, 0.25 times 24. And that time, it'll give us 6. You could do 1/4 of 24, which when you multiply that is 6. Or you can say I want 1/4 of it, divide that into 4 equal sections, that'll also be 6. So the answer is 6 students. So that's our review of box plots. When you're reviewing for the quiz, you're going to want to make sure you can answer the question whether 5, 15, 30, 40, and 49. Do you know for certain whether those were chosen? So kind of going back to numbers 4 and 5. You want to know, Do you necessarily know whether a number inside any one of these sections is chosen? That will be assessed on your quiz and test in this unit. Flipping to the back, we're now going to focus on histograms. This one, it asks us to create a histogram. So let's look at this. It says use the quiz score data to create a histogram below. So these are quiz scores for second hour, and it's everyone's percent. So when I look at that, the lowest we already have the labels here, so we don't even have to worry about that. So the first section is from 50 to 60. Now let's go ahead and make a frequency table. You don't necessarily have to do this. It doesn't tell us we have to do it. But let's over here to the right make a frequency table. So we have, say, frequency. Oh no, this is frequency. And this is the interval. So we go from 50 to 60. 50 we include, 60 we don't include. So there shouldn't be a line underneath that. Okay? We go from 60 inclusive to 70 not inclusive. We go from 70 inclusive to 80 not inclusive. We go from 80 inclusive to 90 not inclusive. 90 inclusive to 100 not inclusive. And then 100 inclusive to 110 not inclusive. Well, as I go through here, I can make this frequency table and say, okay, so 72, that would be in this section. 69 would be in here. 88 would be in here. 77, 89, 77, 91, 83 is here. 58, 62, 75, 82, 78, 88, 100. Now 100 is on the border, right? We need to remember we have 100 between 90 and 100 and 110, 100 to 110. But you only include the lowest number. So in this interval right here, if I want 100, 100 won't be found in between 90 and 100. 100 is going to be found between 100 and 110. So I'm going to put that one down here. Okay. 60 would be, again, that's the one on the border. We have between 50 and 60 and 60 and 70. You only include the lowest number. So 60 is going to be right here. 64 will also be here. 63 will also be here. 99 is going to be down here. 79 we'll find right here. And 94 would be right here. So it looks like we have 1, 5, 6, 5, 3, and 1 as we start doing creating our histogram. So let's create a label for each axis. Well, let's look at here. This right here, we're looking at second hour quiz scores. So I would label this as the quiz score. And we want to make sure we have units. It was percentage. Over here, our vertical axis or our y-axis would be frequency. So frequency, okay? I like to use a highlighter because I think it's easier to shade these in with a highlighter. So we have 1 here, so I'll shade that in as 1. Looks like the next one was 5. The next interval was 6. The next interval was 5. That a little prettier down there. Okay, and the next interval is 3. And then the last one was 1. All right. We also want a title for our histogram. We'll say second hour quiz scores. And now we can answer the questions. Create a label for each axis. Boom, did it. What is the most common score interval and how do you know? Well, the most common score interval is the one that we have the most amount of scores that lie in there. So that looks like it's between 70 and 80. Remember, it's from 70. We include the 70, but we do not include the 80. So it's 70 less than or equal to x, which is less than 80. That is the most common score interval. And how do we know? Well, it's because that's the interval that scores show up in most frequently. That is the interval in which scores show up most frequently. Okay. See, how many students earned at least 80%? So at least means 80% or more. As an inequality, it would mean that the scores are greater than or equal to 80%. When I look up here, 80% is inclusive here, and then we're anything above that. Well, we had 5 here, 3 here, and 1 here. So we would do 5 plus 3 plus 1, or what is that, 9 students. So 9 of the students earned at least 80%. Next question, what percent of the students earned a C? What percent of the students earned a C? Well, a C is in the 70s, so we're in this range. So we had 6 students, but it wants the percent. So we would do 6 out of the total. Well, it doesn't tell us the total, so we could do, this is 5, this is 1. I could add these all up. 1 plus 5 is 6, plus another 6 is 12, plus 5 is 17, plus 3 is 20, plus 1 is 21, so it's out of 21. Or I could look at this and say 1, 2, 3, 4, 5, 6, 7 times 1, 2, 3, 21 students. We could do that. So if I punch in my calculator, 6 divided by 21, I get approximately 0.2857. So this is an approximation. It's the answer goes on forever. So I'm not going to write that it's equal. I'm going to write that it is approximately 0.2857, so on. It doesn't tell us what to round to, so let's round to the nearest tenth. If I convert that to the percent, that would be 28.57%. We just move that guy over twice. But I want to round to the nearest tenth, so I look at the tenth spot, go 1 behind. 7 is greater than 5, so I'm going to round this up to a 6. So this is about 28.6%. All right. Now when we look at this, it says, is the median score or the mean score higher? This is interesting. Which one is higher? Now, we actually have the values. So because I have the values, we could actually calculate the mean or the median. Actually, both of them. But I can also look at just the graph, and we can reason through this. Okay? So if we look at this, this graph is skewed to the right, I believe is right. So we have more values over here and kind of this tail over here. When that happens, that makes us have kind of an outlier. And that mean, in theory, I believe it should be pulled to the right just a little bit. They should be close, but I think the mean should be pulled to the right just a little bit. Let's actually calculate this to double check and see. So we have the mean would add all these up, 72 plus 69 plus 88 plus 77 and so on. So what do we have? We have my 58, 62, 75, 82, 78 plus 88 plus 100 plus 60 plus 64 plus 63 plus 99 plus 79 plus 94. Okay, so I get that they all add up to 1,648. There's a total of 21, we said, so we divide by 21, so we get about 78.4. So that looks about right, right? Like, it makes sense that the average would be about that. So that is the mean. So we know that the mean we actually calculated was 78.476. The median, well, if we just looked at the histogram, we have a total of 21 values. We know the median has to occur in the middle. If there's 21 values, if I take 21, divide by 2, I get 10.5. So that means we'll have 10.5 on either side. Okay, so if we go 1, now we're, and then 2, 3, 4, 5, 6, 7, 8, 9, And so if we go all the way over here, we will have gone 12 values. We don't want to go to the 12th value. We only want 10.5. So we know the median is somewhere in here. And we know we just calculated the mean is somewhere in there. So we can't determine right away whether the mean or median is greater just by looking at this. We know the median has to occur in this interval. So we have to list out all these numbers. So let's go ahead and do it. The lowest value is 58. I'm going to do this in another color. We got the lowest value is 58. So cross that out. So we have 58. The next highest value, I got 60. Looks like that. And then we got a 62 here and a 63. Looks like that's the next. So 62, 63. Looks like we have a 64 and then a 69. So 64, 69. All right, and then moving on to our 70s. We got a 72. Are there any lower? Doesn't look like that. So 72, 75, 77, and another 77. And then we have a 78. I gotta start writing smaller to fit all these guys. 78. What do we got in 79? We got a 82, 83. So 82, 83. We got an 88, 88, 89. I'm going to move down here. 88, 88, 89. Bloop, bloop, bloop. And then 91, 94, 99, 91, 94, 99. Holy smokes, this is taking a long time to put all these in order. Okay, and then we got our 100. All right, so here's our list. Start crossing them off. Bloop, 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 bloop. All right, 78. Okay. So 78 is the median. I guess we could have looked at this. We knew that we had to have 10.5 on one side. We could have just listed these and said 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wait, I must have done something wrong. Oh no, then the 11th, yeah. So we have 10 on one side, 10 on the other. The 2 halves makes that whole number in the middle. So the median is 78. So which one is higher? The mean is higher. Now let's go back to this. Because we have kind of this curve that looks, if I drew this, we have more of a tail on this side. This would pull, that tail pulls that mean closer to the tail, which pulls it higher than the median. Okay, now it's not very much because it's not much of a tail. But as you look at some other graphs in the future, if it is skewed more like this or like this, our median would be here, but the mean would be pulled more that direction. Or let's say it looks more like this with the tail on the other end. Our median would be here and our mean would be pulled that direction. So we'll see more of that coming up soon.